Question 2 is about the bridge, and already I can see from the diagram that we're very likely to be dealing with torque and equilibrium, because it looks like there's supports at both ends, and it's your classic situation of sums of torques and forces adding to produce zero movement. Anyway, moving along. Jackie cycles along a uniform bridge that is supported at both ends as shown in the diagram. It's 25 meters long. It's going to be important information later. It says again the length of the bridge is 25 meters. The mass of Jackie and her bike is 72 kilograms. The mass of the bridge is 760 kilograms. Before I get to the question, I'm just going to label these forces on the diagram because that's useful for me. Center of the bridge is going to be the force that the bridge applies, and 5 meters, 5 meters from the edge, we have, these are not to scale, we have Jackie's force, Jackie and her bike. We'll just call it FJ because we've already got FB for bridge. We don't want to confuse ourselves with similar notation. And there's going to be a support force at either end. We might call those F1 and F2 because we've already got a B. There we go. So, and the size of those will be 12.5 meters. Oh, these are the torques. Sorry, I was getting myself mixed up. We'll just carry on. So calculate the support force FA provided by end A. Okay, that's going to be F1 in my case. And the support force FB provided by the end of the bridge when Jackie is 5 meters from end A. So we don't have enough information to do this with just the forces alone. We know both of the downward forces, and we could tell what the sum of those F1 and F2 would be, but we need to consider the torques to be able to work this out. So we're going to do two equations, sum of the forces and sum of the torques. Sum of the forces equals 0, which means down is going to be my positive, so Fj plus Fb minus F1 minus F2 equals 0. We've already got the equals at the other end. And the values that we know are Fj is 72 kilograms times by 9.8, which is the gravitational field strength in this case, newtons per kilogram, plus F of the bridge is 760 kilograms times by 9.8, and then we've got minus F1 minus F2, running out of space on the edge there, but okay. So we also need to consider the sums of the torques because we've got two unknowns. We need a simultaneous equation, and this sum of the torques, if we create the pivot point, it doesn't matter which at A or B because we have to find both eventually, but if we create the pivot point at point A, so the distance at which F1 is applied is 0, meaning that's a 0 torque, so that's going to eliminate one factor. So then I'm going to consider the clockwise is going to be positive and anti-clockwise negative. So 5 meters, force times distance, 5 meters times by Fj, which was 72 times 9.8. I'm just going to calculate that now. Is 705.6. So that's one torque, plus, because remember anti-clockwise is positive, plus 12.5 meters, which is half the length of the bridge, at which the centre of mass of the bridge, where the weight force of the bridge applies, times by weight force of the bridge, which was 760 times 9.8, is 7,448. And we've also got, we'll better shift this down a little bit, we've got the one more force to include, which is the support force at B at a full length, and this is in the opposite direction, so it's going to be minus, and so 25 meters times by what did I call it? F2, which is FB. So now we want to reduce that down to find F2, then substitute F2 into that first equation. So I'll go to a different colour to make it a little bit clearer. I'm just going to pause the video and solve this equation for F2 because that'll be just a little bit quicker. Okay, just calculated that, gives 3,865.12 newtons. So that is F2, that's the force upward there. So we now know F2 and we know FB and FJ. We can rearrange to find F1. I'm just going to make it go sideways a little bit so we can see how that's going to work itself out. So that going from this equation, we've got 72 times 9.8, which was 705.6, plus 760 times 9.8 was 7,448, and then we have to, I'm going to minus F2. Minus F2 we worked out was 3,865.12, and that should equal F1 with a small rearrangement thrown in there already. So that equals 4,288.48 newtons. And that's a reasonable answer. We would expect it to be larger than FB. This is F1 or FA in the diagram. And so we'd expect it to be larger because the bike is closer to that end. Okay, B. Question B. Express your answers to part A to the correct number of significant figures and give a reason for your choice of significant figures and your answers to part A. Okay, let's see. Everything seems to be given. Remember, with your significant figures, when you're multiplying or dividing, you have to use the least number of significant figures as your limiting factor. So that's the reason. We've got 3 significant figures here, 2 significant figures here, 2 significant figures here, and 5 meters from the end is also 2 significant figures. So we do have multiplication and division in our answer. So the rule is to use 2 significant figures. So our 2 answers should be F1 equals and F2 equal, I've got F2 right here, so I'll write that. 2 significant figures, that means the 6 rounds up to 9 for the 3, so it's going to be 3900 newtons to 2SF, and I'm quoting the SF because then I'll know that I haven't made a guess at it, and 4,300 will be 2SF for the other one, for F1. Oops, 4,200 newtons also to 2SF, and I've done 2SF because multiplying or dividing use least SF. Okay. Question C. While Jackie is cycling at a speed, we better go to a different colour, at a speed of 16.8 meters per second, she collides with a soccer ball that is rolling towards her at the speed of 8 meters per second. This sounds like a momentum or impulse type of question. Soccer ball bounced off in the opposite direction with a speed of 5 meters per second.